Introduction. Akash, do you know about the composition of gases in air? Yeah, air is a mixture of approximately 79% of nitrogen and 21% of oxygen. Good, you are right. But there are also some other gases present in the air. These gases are known as noble gases. Noble gases are present approximately 1% in air. Okay, and what are the names of these gases? Neon, argon, krypton, and xenon, all together known as noble gases. Akash, don't you know that these elements are the members of P block in the periodic table? No, I don't know, but I want to know more about it. Fine, let's move to understand more about P block elements. Students, now we will study about the 17th and 18th group of the P block elements.
Objectives. At the end of this lesson, you will be able to define group 17 elements, explain physical and chemical properties of group 17 elements, describe halides and oxides of group 17 elements, analyze anomalous behavior of fluorine, explain manufacturing and properties of chlorine, know about interhalogen compounds, define group 18 elements, explain physical and chemical properties of group 18 elements. Group 17 elements, the halogen family. The non-metallic elements fluorine, chlorine, bromine, iodine, and astatine constitute group 17 of the periodic table. Their salts are present in seawater and hence they are collectively known as halogens. The general electronic configuration of halogens is Ns2np5. They have a very strong tendency to acquire stable inert gas configuration by accepting one electron. For this reason, halogens exhibit non-metallic behavior. Astatine, the last member of halogen family, is a radioactive element with a very short life. General trends in properties. Atomic and ionic radii. Atomic and ionic radii are small and increase regularly down the group from fluorine to iodine because new electronic shells are added. Ionization enthalpy. Ionization enthalpies of all halogens are very high. Therefore, they have a lesser tendency to lose electron. However, this tendency increases down the group because the distance of valence shell from nucleus increases. Electronegativity. They have a very high electronegativity. It decreases down the group. Fluorine is the most electronegative element in the periodic table. Electron affinities. They have high values of electron affinities. On moving down the group, electron affinity values decrease because size of the atom increases. A low value of electron affinity for fluorine is due to the small size of fluorine atom. In a compact 2b subshell of fluorine, the added electron does not feel much attraction, resulting in low value of electron affinity. Physical properties of group 17 elements. Melting and boiling points. Melting and boiling points increase with increase in atomic number. This indicates that the strength of intermolecular forces of attraction between the molecules increases with the increase in atomic number. Physical state. The halogens are all diatomic and exist as F2, Cl2, Br2, and I2. The intermolecular forces are very weak in halogens. The nature of forces in van der Waals and their magnitude increases down the group. Thus, F2 and Cl2 are gases, bromine is a volatile liquid, and iodine is a volatile solid. Color. The color of the halogen is due to absorption of visible light by their molecules, resulting in the excitation of outer electron to higher energy levels. The color deepens down the group. Oxidation states of halogens. All the elements of the halogen family have a tendency to acquire noble gas electronic configuration by either accepting an electron resulting in the formation of monovalent anion or by sharing one electron with those of the other elements. Thus, they show an oxidation state of -1 or +1 depending on whether the element combining with halogens is less electronegative or more electronegative than halogen. Fluorine is the most electronegative element, and it always has -1 oxidation state and never has a positive oxidation state. Also, higher oxidation states are not possible in fluorine as it does not have vacant d orbitals. Other elements of this group show oxidation states of +1, +3, +5 and +7. Higher oxidation states of these elements are due to the presence of vacant d orbitals. Chemical properties of group 17 elements. Some important trends in the chemical reactivity of the compounds of these elements are following. Hydrides. Halogens combine with hydrogen to form volatile halides of the formula HX. Except HF, all other hydrides HCl, HBr, HI are gases. HF is a liquid because of intermolecular hydrogen bonding. The bond between hydrogen and halogen is covalent in all the cases. All the hydrogen halides act as acids in their aqueous solutions. All the halogen acids ionize to give H+ ion and halide ion X-. The reducing character of the hydrides increases down the group. It is because the strength of HX bond decreases from HF to HI. Halides and group 17 elements. The halogens react with almost all the metals and non-metals. With metals having low ionization energies, the halogens react to form ionic halides which have got high boiling and melting points. As the electronegativity of the halogens decreases down the group, the ionic character decreases. For example, SnCl2 and PbCl2. With metals having high ionization energies, the halogens form covalent halides, for example, SnCl4 and PbCl4. With nonmetals, the halogens readily form covalent halides, for example, PF5 and PCl3. Oxides of group 17 elements. Halogens do not combine with oxygen directly. For example, oxygen difluoride OF2 is prepared by action of fluorine on 2% sodium hydroxide solution. The compounds of oxygen with fluorine are called fluorides because fluorine is more electronegative than oxygen. Most of these compounds are endothermic and unstable and are likely to explode, resulting in the formation of more stable products. Among oxides of each halogen, the higher oxides are relatively more stable. All of the oxides are powerful oxidizing agents and decompose explosively when subjected to mechanical shock or heat. Anomalous behavior of fluorine. Fluorine has very small size, very high electronegativity, high ionization enthalpy, and no d orbitals in its valence shell. It exhibits some different behavior from other elements in following ways. Bond dissociation enthalpy of F2 is low. Therefore, F2 is very reactive. The compounds of fluorine have maximum ionic character. The hydride of fluorine is liquid due to molecular association by intermolecular hydrogen bonding. It always shows an oxidation state of -1. It does not form polyhalide ions due to the absence of d orbitals. Chlorine. Chlorine is too reactive to occur in uncombined state in nature. It is widely distributed in combined state as chlorides of Na, K, Ca and Mg. It is usually prepared by heating concentrated HCl with MnO2. It can be prepared by heating a mixture of NaCl and concentrated H2SO4 with MnO2. The gas is passed through water to remove HCl and then dried by passing through concentrated H2SO4. Pure chlorine gas is obtained by dropping concentrated HCl over solid KMnO4. Manufacturing of chlorine. Commercially, manufacturing of chlorine is done by the following methods. Decans process. In this process, hydrogen chloride gas is oxidized with air in presence of cuprous chloride catalyst at 723 Kelvin. It is also manufactured by electrolysis of fused NaCl using lead as cathode and carbon as anode. Chlorine is also obtained as a byproduct in the manufacture of NaOH either by Caster-Kellner or by Nelson's process. In this reaction, a saturated solution of NaCl in water is electrolyzed. Properties of chlorine. It is a greenish-yellow colored gas with a characteristic pungent and suffocating smell. It is moderately soluble in water and forms a pale yellow solution which smells of chlorine. This solution is called chlorine water. In dark there is no reaction, but when a mixture of H2 and Cl2 is exposed to sunlight, reaction takes place with explosion. On heating, it directly combines with a number of elements. It is a good oxidizing agent. In presence of moisture, it acts as a strong bleaching agent. It reacts with organic compounds. With saturated components, substitution takes place. But with unsaturated compounds, addition reactions take place. Uses of chlorine. The important uses of chlorine are following. It is used in the extraction of metals like gold and platinum. It is used in the manufacture of poisonous gases like phosgene and mustard gas. It is used in the manufacture of CHCl3, CCl4, PVC, DDT, and BHC. It is used for sterilizing water for industrial and domestic uses. It is used for extracting bromine from bromides. It is used as a bleaching agent for vegetable and organic matter. Hydrogen chloride. In 1648, Glauber obtained hydrogen chloride by heating common salt with concentrated sulfuric acid. It is a colorless gas with a sharp penetrating smell and acidic taste. It is extremely soluble in water. 1 volume of water dissolves about 450 volume of hydrogen chloride under ordinary conditions. It can be easily liquefied to a colorless liquid or frozen to colorless solid.